Today we will be solving round 963B Parity and Sum, where you are given an array A of n positive integers. You can pick any pair of indexes such that both numbers have distinct parity. Then you have to replace the smaller one with the sum of them. You need to find the minimum number of operations needed to make all elements of the array have the same parity. Okay, so first of all, simple corner case. If all are odd or all are even, then answer is directly 0. Else, we have to perform these operations some number of times. Now, since we need to use a of I and a of j both of distinct parity, which means one is going to be odd, one is going to be even, and the sum for odd and even will always be odd. Hence, if there are a mixture of odd and even numbers in our array, that means we always have to convert all the elements into odd. Because if you are adding odd and even, you will never get an even number. You will always get an odd number. Hence, your goal should be to convert all the elements into odd. Now, the operation says that we replace the smaller one with the sum of them. So let's say your a of I is your even number and a of j is your odd number. So your even number becomes even plus odd. Hence in one operation you can complete means in one operation you can convert that even to odd if your odd is bigger, and we need the minimum number of operations. So we will try to perform this operation as many number of times possible. If we have a very larger odd and we have a very lesser even, then even will be converted to odd by addition, and by one operation one even will be converted to odd. Okay, so I'll explain you with this test case 2, 3, 4. We chose the greatest odd number and the smallest even number, since the greatest odd is less than the smallest equal number. 2 becomes 2 plus 3 and it becomes 5. Now my array is 5, 3, 4. My greatest odd is 5. My smallest even is now 4. So 4 becomes 4 plus 5 and 4 becomes 9, which is odd, and my answer is 2. Now what do I have to do if my odd is less than my smallest even? Like let's say we have 3, 6 and 4. So my biggest odd is less than my smallest even. In this particular case, you will have to perform two operations. Why two operations? Since 3 is less than 4, 3 will first become 3 plus 4. And now as you see, now 3 has become bigger. So now it turns into 7 and 11, and hence in two operations I have turned my even into odd. But now, do I have to choose the smallest even in this case or the greatest even? Because as you can see, if our odd is greater is greatest possible, that means I will get lesser operations. If my odd is less, then I will get more operations, since I will have to perform more operations of type 2. So if I have a case like this, like my greatest odd is less than my smallest even, then I will not use my smallest even. I will use my greatest even. Why? Let's say we have 3 and 6. If we have 3 and 6, in one operation this becomes 9 and 6. Second operation 9 and 15. If you see, I have got a greater odd. If I had used 3 and 4, I got 7 and 11. But here I have got 9 and 15. So I have got a greater odd, and hence my chances that I will be requiring less operations in the later array will increase. So this is our main logic. First of all, we choose the greatest odd number from our current list and our smallest even. Okay, if this is true, then we just make addition and this becomes odd in one operation. But let's say the smallest even is greater than the greatest odd. Then we will use the greatest even. In this case, we use the greatest even. And now we add both, like greatest odd becomes greatest even, greatest odd plus greatest even, and this adds over here. So you get a higher odd in two operations. Now I'll show you how to implement this. I will submit C++ code as well after the contest ends. I will try to explain the syntax as easy as possible. This is my priority queue which contains odd numbers. Collections on reverse order makes it that my peak element will have the greatest odd number. This is an ordered map which will store all even numbers. Now while even dot size is more than 0, I find the smallest even and the greatest odd. If my greatest odd is more than my smallest even, I remove my smallest even, make it odd by performing my operation and add that to my priority queue. Answer plus plus continue. Else I use the greatest even. Last key means the highest key. So greatest even. Then I remove that and hence I will have to perform two operations. Then first I will have to add the high. Then first I will first I will have to add the greatest even to the greatest odd. Hence this. And then I add this back over here. So two operations. Then I will have to remove my current odd because that has been increased. So I remove this and add both of these to odd. Then I print my final answer. Okay. So thank you guys for watching. Make sure to like, share and subscribe to never miss another tutorial.